Hey, good morning. All right, wanted to follow up from my previous short. I'll be the first one to admit, for the longest time, I was under the presumption that the failure mode within these engines were initially the lifters, whether it was, the stack up tolerance between the roller, the needles, and the axle. This happened between 70 and 150,000 plus miles. Obviously there's other assumptions out there, MDS related, oil pressure, all that other stuff, and I'm not gonna argue that those aren't variables, but in my situation here, the root cause, and I'll walk through it, was induction hardening on the camshaft. Here obviously this is the flow through the engine. Crankshaft spinning, the cam here, this is the front, turning into the lifters, push rods going through the head into the rocker assembly, making the valve function up and down. If this thing is spinning clockwise, let me get some light here. Most of the base circle transitioning into the lobe in number 3 and number 7 are the worst, and you'll know one of those is not an MDS cylinder, so that's out the window. Obviously this is also happening to manual cars and heavy duty trucks previously without the MDS system. Hardness was checked on the roller and the camshaft. Once we're through the hardening, you can see the shell, the induction hardening shell. You're losing 4 to 5 points of Rockwell C hardness, and it's consistent with what the journal. I took some of the journal as well, because that spun after the fact on the lathe. And then here's number 7 intake. Pointer. Number 7 intake. And then I just wanted to touch on number 8. It's like one of those pieces of hardening debris got caught between the lobe and the lifter roller. They cut costs with the cam, cast core cam, and then just decided to harden it. But that's kind of the deal. It's warranty. They're hoping to get out a warranty period, and then these things start falling apart. Eventually what happens, take a look at number 3, and would have happened to me. All my rollers, axial, radial play, perfect. Diameter of the roller itself, all test great. You can see there's transfer of delamination from the cam on a lot of these, and it's not the roller. How can we prevent this from happening, or shorten the time until what's going to happen is over time, as the roller is meeting that contact point and there's friction there from the roughness of the cast core, it's briefly and momentarily stopping every time there's a revolution there, and it'll keep digging away at that, and to the point where one of the rollers, or I should say the entire roller, will seize up, and it'll just start working its way through the core and create enough heat to start wearing out that roller. And flat spot, you get down to the ears of the housing, and wreaks havoc, possibly killing your entire engine if that goes through self-bearing surfaces. Based on 2 of my push rods, they were light on preload into the spring. So every time it's transitioning from the base circle of the cam to the peak lobe, right there, it may be making an impact depending on RPM and the control oil pressure, all those are variables. But, you know, it comes down to preload. Preload on the spring, eliminating any jump transition from those 2 points. And I mean, you think about an engine, these things spin 6,000 RPM. This camshaft here, that camshaft is spinning 50 times per second. And you're trying to control that entire assembly through the valve to get air in and out of here. There's obviously an issue. Not saying that this is going to happen to every single one. It depends on usage, loads, obviously, again, those variables. But I would say for the majority, and we're seeing the percentages now really come to light because of the forums, social media, everything. And I don't want to get into oil this, debate that, pressure. The engineers, obviously, and I'm an engineer myself, manufacturing and design process. I do root cause and PFMEA, failure mode effect analysis on, you know, all this PPAP stuff. I was in automotive for 10 years. I'm out of it now, and those of you up in corporate know, you know, the reasons for that lately. There's zero tolerance for late shipments or defective components, and unfortunately in American manufacturing, it's just not feasible with the labor and workforce that we have to work with. Transitioning to robotics as much as you can, but this is all